Hello again, MoNaCo here, and Milk's behind the camera.
Woohoo!
The last video I showed you the flame test with the solid elements, the solid compounds in the flame, how the different elements gave different colors. Here what we have is called a gas discharge tube. It's high voltage. So in the previous video I showed you heat exciting electrons. Now I'm going to use electricity to excite electrons. And instead of solids, I'm actually doing gas. This is a glass tube. Inside this tube, we've replaced all the air with neon, so a pure element. And
Ooh, we've seen neon signs before.
This is the basis of the functionality of all neon signs and all glowing lights. This one's chlorine. This one here is helium. And the last one in here we've got, oh, I remember, it's hydrogen.
Turn it on, turn it on.
So when I turn it on, the electrons are traveling to the anode, from the anode to the cathode. As they travel through the gas, they excite the gas. So the electricity from the voltage here is exciting the gas, taking the electrons in the element hydrogen from the ground state to the excited state. They don't stay there very long. They relax back down and they give us off these awesome colors. So hydrogen gives us a nice purple color.
Right, now just because I'm the camera guy, I'm gonna tell you, it's like this light blue on the edge and it's like magenta-y purple in the middle there.
Yeah, I don't know if the camera's catching it.
Well, we're gonna see how it is when we replay it. But
hydrogen, cool purple. Okay, if you looked at it through a spectroscope, you'd see the very specific wavelengths of light that are mixed together to make this purple. Now I'll switch it. It's a little warm. This gets hot. The longer it runs, we'll do chlorine now. So different element, different electrons, different electron configuration. Boom. Different color of light.
We can definitely see in the video that's a different color of light all the way through. Definitely bluer.
The first one was purple magenta. This one's like kind of a sky blue almost. Okay,
nice.
So that's chlorine, different element, different electrons, different spectral fingerprint, different color. You can use these different colors that the elements are burning, so to speak, in order to identify them. This one is helium.
Ooh.
Helium, helios, the sun, yellow.
Very
it's
yellow.
no coincidence that our sun burns this bright, bright yellow color because there's a lot of helium in our sun.
I can see the yellow reflecting off here in the video real good. This looks a little bit oranger in real life to us.
Yeah, so our sun is a yellow sun because it has a lot of helium in it burning.
Beautiful.
It's not actually burning, it's just getting excited and it's relaxing back down to the ground state. Last one, the neon for the neon signs, to give you the namesake. All the neon signs out there were based on this original technology. Neon was a brilliant, bright red when it was excited. So it caught. The name neon was used to make all the original neon signs, which were originally just red.
Right. So those of you guys in video world, if you see this as yellow here, like I'm seeing on the screen, I can see the red hue, and definitely MoNaCo's shirt is lit up red right now.
Red color.
But it's so vibrant red for us, it's almost blinding the camera.
And remind us, Mr. Milks, you're always good at bring us back down to ground state. Why is each element a different color?
Because each electron and each energy level has a different energy associated with it.
Because it's a different distance from the nucleus.
Right.
And as it relaxes back down to the ground state, these are excited right now, I'm gonna turn it off. All the gas went back to the ground state. In the ground state, it doesn't give off energy. Only once you excite it and then let it come back down, it gives off the colors that we see.
Very good.
You can use these different colors in the spectral fingerprint to identify the unknown elements, which is the whole reason why we did this lab. Thanks for watching.